Hi, my name is Braden and welcome to my analysis of the employee attrition dataset. Alright, so the bottom line up front, we have our top 3 factors contributing to attrition as overtime, job level B, and I'll explain that B here momentarily, and stock option level. And so we found these top factors via a variety of methods, which we call filter-based feature selection, distributional analysis, and wrapper-based feature selection. And I'll explain what each one of these are next. So our first filter-based method is the relief score. And so what the relief score measures is a distance between the classes, so between attrition and non-attrition, within a particular feature space. And so the way the algorithm does this is that it first randomly samples an observation and checks what class it's in. And so next, it'll find what it calls the closest hit and the closest miss. So the closest hit would be the closest observation of the same class, and the closest miss would be the closest observation of the opposite class. And so the way the score gets developed is that if your closest hit is close by, then the score goes up. But if your closest miss is also close by, then the score goes back down. And what we can see here is that our top 3 factors from the prior slide all perform very well under this metric. And so next we have the random forest feature importance score, which is simply utilizing the random forest model's built-in feature selection system. And again, we see our top 3 factors all performed very well under this metric. Okay, next we have what we call a proportion plot, and I'm going to show you several of these plots. And so the first thing to know about all of these kinds of plots is they're all going to have this red dashed line, which is simply a reference point that shows the overall proportion of attrition regardless of anything. So that's just the data set. So within the data we were given, about 16.1% of people left the company. And so next, what this kind of plot can do is it breaks down the proportion of attrition within the levels of a categorical variable, in this case overtime. And so what we can see is that for individuals who did not work overtime, the proportion of those people who left the company was less than 10%. But for those who did work overtime, the proportion was over 30%. And lastly, these plots have these bars attached to the point estimate. And what that represents is a 95% confidence interval for the proportion. So what we can see is that even with the uncertainty in the estimate taken into account, there's still a significantly higher proportion of people working overtime leaving the company as compared to those people who do not work overtime. Okay, next we have a similar type of plot, but this time for the stock option level feature. And what's really cool about this plot is that it really captures the entire career life cycle. So we can see people with a low stock option level tend to be early in the career, and a higher proportion of those people leave the company. As people progress in their career, stock option level goes up and the proportion of attrition goes down until we reach retirement age, where people with the highest stock option level start retiring, and the proportion of attrition obviously goes up for those individuals. Okay, as promised, we have job level B, and so this B stands for binned. And so first over here on the left we have the original job level feature, and there's 2 things to notice about this plot. The first is that people with job level 1 have the highest proportion of attrition, and the second thing to notice is that people with job levels 2 through 5 have a lower but similar proportion of attrition. Okay, and so on the right we have the binned version, where we've taken groups 2 through 5 and combined them into a single group. And so there's 2 benefits to doing this. So the first, as you can see, in this combined 2 through 5 group, the error bars are much tighter, so we get a much better estimate of the proportion of attrition within the group. And next, what we've done is we've simplified the relationship. So if we can take 5 bins and make it 2 bins without losing too much information, then we have a simpler relationship for our model to learn. Our model will be more productive at finding the relationship between job level and attrition. Okay, now let's take a look at the models. And so focusing first on this first row for naive Bayes, the first nice thing about naive Bayes is that there really isn't any hyperparameters to tune. And so next I want to point out the features used. And so our best naive Bayes model used 12 predictors. And so the way these 12 predictors were found is that we started off with a set of 16 candidate predictors found using the filter-based methods, and then we created all combinations. And so each one of those 16 by themselves, all groups of 2, all groups of 3, all the way up to all 16 together. So that was over 65,000 candidate models. And so for each one of those, we fit a naive Bayes model and used tenfold cross-validation to get the training and test metrics. And this combination of features was our highest performing in the naive Bayes group. So next we go on to KNN models, and KNN does have a hyperparameter to tune. And so to balance the computational load, we started off with 13 candidate predictors. That was a little over 8,000 candidate models, but for each one of those models, we found the best value of k, so the best number of neighbors. We tried out 25 different values of k, so starting with k equals 1 up to k equals 51, incrementing by 2. And within all of those models that we tried, we found that k equals 1 with these 6 predictors had the highest training and testing metrics via tenfold cross-validation. And so lastly, the support vector machine is a lot more expensive to fit, so we utilized a random search, and we used only hand-selected groups of predictors that seemed to perform well via the filter-based methods. And here are the metrics for our highest performing SVM model. Okay, so now predicting monthly income with linear regression. We used a similar approach as the KNN and naive Bayes models previously discussed to come up with the best predictors to use for our linear regression model, which turned out to be these 4: education, job level, job role, and age. And we found a training RMSE of a little over 1,000 and a very similar test RMSE, which shows that this model was not overfit and also was very accurate at predicting monthly income. Lastly, job-specific trends, and so we can see sales representatives have the highest attrition. All right, any questions? And thank you for your time.